Good evening, students. Today we have come with a new chapter, that is problem solving for class 11 computer science. In this chapter we will learn how to solve a problem. Problem in the sense that problem of computing, writing programs, doing programming. During writing programs, we have to face lots of problems. So to solve a problem in computing, we have here we will discuss lots of different ideas, different techniques, methods to solve a problem. See, first of all, we will understand what is problem and how we can solve it. There are a number of problems in our day-to-day life. In our daily life, in our real life, there are so many problems also. So many problems day-to-day life. Such as developing mark sheet. Suppose mark sheet is to be developed, calculating simple interest. So many problems depending on the calculation work. Working with the computers, we face lots of problems in daily life. All these small or big problems require proper problem solving mechanism. Proper problem solving mechanism. So to solve all these problems, small or big problems, we need problem solving mechanism. There should be a mechanism, there should be a technique, there should be a method, step-by-step method to solve a problem. And this chapter deals with these things, with solving with the problems. Problem solving is the act of defining a problem. Act of defining a problem. It means we have to first understand the problem, define the problem, what is the problem, we have to know about the problem, and then determining the cause of the problem. Why the problem occurs, we have to find that, and then identify the areas of the problems, and then prioritizing means which problem is to be solved first, or which problem we have to face first. Find the solution for which problem, we have to prioritize all these things, and then selecting alternatives for a solution. Suppose we do not find any solution for a problem, then we have to find some alternatives to solve that problem, and implementing a solution, and then we have to implement the solution. See here. Steps to find solution of a problem. We have given here some steps to find solution of a problem in the sense of a computing. Not our real problem, just a computing words. Writing programs, doing with programmings like this. We have to find solution. See, a complex problem also in the same time, by this method we can also solve our day-to-day life, real life problems also. If we understand these concepts and solve the problems of our computing works like writing programs, then we are also able to solve our real problems. But we are not discussing about those things. We are discussing here about solving the programming related problems. So a complex problem requires a methodical approach to find the right solution, and we know that a complex problem, if we are having some complex problem in a real life also, it requires a methodological approach. Methodological approach means a step-by-step approach. One after another, one work after another, solution after another solution, to find the right solution. Yes. Problem solving begins with the precise identification of the problem and ends with a complete working solution in terms of a program or software. Okay, now what is this? We have to begin with precise identification of the problem. First we have to identify the problem precisely. Each and every stone we have to turn to understand the problem. Okay, and then ends with a complete working solution in terms of a program or software. Okay, now understood. We are going to solve a problem to write programs and softwares. Okay, now here given the key steps required for solving a problem using a computer are, these are the key steps. We have to follow these steps. First step is the analyzing the problem. Analyzing problem means understanding the problem. Developing an algorithm. What is algorithm? Just a step-by-step solution of a problem is known as algorithm. We will learn about these things, just we are coming to that point. Okay, now third one is coding. Coding means writing the program in a programming language. Then testing and debugging. Then we have to test the program that it is working or not. Okay, and then if there is error, we have to do debugging. Debugging means first of all, bug means error. Here bug means error in computing. Okay, and debugging means removing error. Then one by one we will remove the error, and then we make the program error free. What we have to do first? Analyzing the problem. See here, what is analyzing means? Okay, it is important to clearly understand a problem before we begin to find a solution for it. Okay, important to clearly understand a problem before we find solution. Okay, first step is to understand the problem. Okay, if any problem we find, if suppose during running a program we will find some errors, don't think about the error first. What is the error? Don't think about the solution. Okay, first understand what is the problem, why this error comes. Okay, this is the important thing. This is the first step to find a solution for it. So we need to read and analyze the problem statement carefully in order to list the principal components of the problem. Okay, why we analyze the problem, why we clearly understand the problem, why we carefully understand the problem? Because we have to find a list of principal components of the problem and decide the core functionalities that our solution should have. Okay, we have to find the core functionalities that our solution should have. By analyzing the problem, we would be able to figure out what are the inputs. Now, so understand, by analyzing a problem, okay, and to find the solution for the problem, during analyzing we find that what are the inputs, that our program should accept, okay, and the output that it should produce. Okay, during analyzing we figure out, we understand that what are the inputs needed to run the program and what output it will give the output, what output the program will be should be produced, and the output is not producing because there is error, and that's why we are analyzing the problem. Okay, so at that time, at analyzing, we understand what are the inputs and what outputs should be produced by the software or the program. Okay, now developing an algorithm. Now we understand the problem, we precisely know the root cause of the problem, and then after then we are here developing an algorithm. Algorithm means to find the solution of the problem. Okay, it is essential to devise a solution before writing a program code for a given problem. Okay, devise a solution. Using by algorithm we will devise a solution, okay, before writing a program code for a given problem. the solution is represented in the natural language. Okay, there is no code word, there is no programming word, just a natural language, just a English like language. Okay, and that is called algorithm. In English like language we will find solution, step-by-step solution, and this is called the algorithm. Okay, by the way, we will learn algorithm in detail later. Okay, we start with a tentative solution. Tentative solution, just a temporary solution. Tentative means temporary solution plan, and keep on refining the algorithm until the algorithm is able to capture all the aspects of the desired solution. Okay, refining the algorithm. Now we keep on refining, we keep on modifying, upgrading the algorithm to capture all the aspects of the desired solution. To find the desired solution, we keep on upgrading, we keep on changing the algorithm. Okay, now in developing an algorithm we have to write, okay, write program code before we have to write solution for the problem, okay, in natural language. Okay, and this is called algorithm. Understood? We will see examples also. Now next, the third step, this is the third step, is coding. Coding means after finalizing the algorithm, once we have written the algorithm, we need to convert the algorithm into a format which can be understood by the computer. Now in a format understood by the computer, okay, we have to convert this algorithm into computer understandable code, that is in a programming code. Okay, different high-level language, programming languages, okay, can be used for writing a program. Now in any language, in high-level language, in C language, C++ or Python language, we will learn in this class, we will learn in computer science, we will learn Python language. Okay, in Python language we have to write program after what? After writing, finalizing the algorithm, then only we have to write the program. Okay, now it is equally important to record the details of the coding procedures followed and document the solution. Okay, now there are two things. Okay, first coding and then documenting. Two things here. Both are said that it is saying that both are equally important. Both are equally important. What is coding and documenting? Coding means we have to write the programs, okay, in a programming language. At the same time we have to write the document for the solution, means in natural language, in English words, we have to write the solution of the problem. Okay, documentation. This will help in later stage when the software is fully developed and used by the end user. This document will be helpful in modifying the software, in understanding the software for any person, for other person also. For that purpose documenting is important. So it is saying here that equally important during writing coding, during coding, okay, we should also document the solution. Okay, this is helpful when revisiting the program at a later stage. Okay, helpful in later stage. So that's what we have to document. Now this is the last step, testing and debugging. First we should understand what do you mean by testing. Testing means we have to execute, we have to run the program, and we have to test the program by known set of values. Known set of values means we already know the output of the value which we are going to input into the program. Okay, for that purpose, that the program or the software is giving the desired output or not. For that purpose testing is needed. Testing means we have to execute the program and then we have to check all the aspects of the program, and then if there is any error is found, then we have to debug it. Debugging means we have to make it error free. Bug means error and debug means we have to make it error free. Now understand here, the program created should be tested on various parameters. Okay, tested on various parameters. The program should meet the requirements of the user. Okay, should meet requirements of the user. Okay, it must respond with the expected time. Okay, expected time, respond within expected time. Okay, within seconds it will respond. It should generate correct output. Now what correct output should generate? Okay, for all possible inputs, whatever input it is asking, we are giving that output, and then it will give the correct output. In the presence of syntax, now during these phases any errors may occur, and these syntactical errors, okay, no output will in the presence of syntactical error, no output will be obtained. Okay, if error is there, we will get no output, or if we are getting output, that output will be wrong or not correct. In case the output generated is incorrect, sometimes output is generated but it is incorrect, then the program should be checked. Okay, checked means tested for logical errors also. Some syntactical errors are also there, some logical errors are also there, if any. The errors or defects found, okay, errors or defects found in the testing phase are debugged. Now debugging is needed. Debugging means, or rectified means making the correction in the program. Okay, program, and then again tested. Then after making error free, the program again must be tested again. Okay, so that we satisfy that it is working properly. Now this continues till all the errors are removed from the program. Okay, this is known as testing and debugging. Okay, during testing and debugging, we have to check the program, execute the program, and test the program with the known set of values that the output is giving, correct output is giving or not. If not giving, then we have to do debugging. During debugging, we have to make the program error free and then retest the program. This okay, this cycle will go for after testing. Debugging is needed if any error is found, and if error is rectified, then again testing. Okay, this should go on until all the errors are removed. Okay, now this is the process. Okay, what are the 4 steps? First, understand the problem, create a plan means write the algorithm, execute the plan means write the code, code in a programming language and execute it, and then check it and reflect it. Check it and reflect it means make changes and then check again and find that desired output is coming or not. Now see here, the above described stages, all these are the stages of problem solving, help in developing computational thinking, in turn proper, accurate and complete solution to a given problem. We get complete solution for the given problem if we follow these steps, okay, precisely. Algorithm. What is an algorithm? An algorithm is a step-by-step solution of a problem. In algorithm, we give some input and there are a set of rules to obtain the expected output from the given input and give us the output. Okay, this is the algorithm in one way. Now here in detail we will learn what is algorithm. In our day-to-day life, we perform activities by following a certain sequence of steps. In our day-to-day life, we perform activities by following a certain sequence of steps. Yes, activities is performed by sequence of steps. Say for example, if we are preparing some dish, okay, so what we do, we start with some utensils, then ingredients, okay, and then we pre-process these ingredients, and then finally some dish is ready to serve, like this. Okay, in day-to-day life we perform so many activities and follow a sequence of steps. Now to complete each activity we follow a sequence of steps. Yes, to complete also, to perform also, and to complete also each activity we follow a sequence of steps. Now what is this algorithm? This is the algorithm. An algorithm is defined as a step-by-step procedure designed to perform an operation. Okay, what is step-by-step procedure designed to perform an operation or the activity which will lead to the desired result, which will produce as desired result, which what the result we wanted, it is producing. Okay, and if followed correctly, okay, if the step-by-step procedure is followed correctly, the desired output is produced. This is known as algorithm. Algorithm has a definite beginning, means a beginning step is marked, and definite end, and end is also marked, that here from here we have to start the algorithm and this is the end of the algorithm. It is marked there, and consists finite number of steps. Okay, finite number of steps means we can count the number of steps. There is no infinite, there is finite number of steps, means we can count 1 2 3 like this count, that it is having 5 steps, it is having 7 steps. This problem can be solved with the help of 10 steps, like this it is defined in the algorithm. Okay, so what is the algorithm? It is a step-by-step procedure designed to perform an operation which will lead to the desired output if followed correctly. Now this is the example of algorithm. See, an algorithm to find average of 3 numbers. Okay, to find average of 3 numbers, what we do? We add all the 3 numbers and divide the number by 3. This will give us the average of the number. To solve this problem, how we can write the algorithm? See, we have to write first step 1, like this: step 1, step 2, step 3, step 4. Then in a step we have to clearly mention what input we need. Okay, read values for A, B, C, like this. In English, like a structure, English like words. Okay, then compute average AVG equals to A plus B plus C divided by 3. This is formula is given, okay, for processing. Now print result is average. Now if it is calculated, then the result is called AVG, and then the print message will display the AVG result, and then stop message is given here, that here the algorithm is complete and we must stop it. Okay, why? Now we already understand why we need algorithm, just we are going through in detail here. Writing an algorithm is mostly considered as a first step to programming. Okay, it is the first step of a programming. Algorithm writing is first step to programming. Once we have an algorithm to solve a problem, now we have written an algorithm to solve a problem, we can write computer program also. Okay, if algorithm is there, then computer program can be easily written. Okay, in any programming language, whatever programming language we know, we can write computer program. First we have to write the algorithm. We are having an algorithm for giving instruction to the computer in high level language. High level language means a computer, actually high level, so many types of languages are there: low level languages and high level languages. Low level language are binary language, that is must be written in 0101 format. Okay, which is very much difficult to write for programmer like us. Okay, and in high level language, the codes are written in English like a structure, the commands are like English like a structure. Okay, and it is easier to write programs in computer language. Okay, so in high level language we have to write the program. If the algorithm is correct, computer will run the program correctly. Okay, if the algorithm is correct, okay, then program is also correct. Program is also correct every time. So the purpose of using an algorithm is to increase reliability. Okay, reliability, trust, okay, then accuracy and efficiency of obtaining solution. Okay, obtaining algorithm, why we need algorithm? Okay, it increases reliability, accuracy and efficiency of obtaining solution. Means To obtain a solution, to find a solution of the problem, this algorithm gives us accuracy, efficiency and reliability. Okay. Now see characteristics of an algorithm. So many characteristics are there. Well-defined inputs. Okay. In algorithm, inputs are defined exactly how many inputs is required, where we will take inputs. Okay, well-defined outputs, what will be the output of the program. Okay, it is also defined. Clear and unambiguous. It is clear, step by step is given, 1 step, 2 step, 3 step. Okay, start, position, where we have to start, where we have to step. So, okay, it is clearly mentioned, everything is clearly mentioned. Okay, and there is no confusion. And then language independent. Okay, it is in natural language, English language. So it is language independent in respect to computer languages. So, computer languages are having various types of computer languages: C, C++, Java, Pascal. Okay, so many types of language, Python. Okay, so it is in English language, it is independent of all the language. So if once algorithm is developed, once algorithm is generated, okay, algorithm is written, we can write program in any language. Okay. Now finiteness means there is a finite number of steps, we can count the number of steps. And feasible means possible steps are given there. Okay. Now characteristics of good algorithm. Previously we have learned all the characteristics of an algorithm. Now we are understanding here characteristics of a good algorithm. Okay, what are the characteristics of a good algorithm? First, it should be precision. Precision means every steps are precisely stated or defined. Each and every steps must be defined, step 1, step 2, step 3, like this. And uniqueness means results of each step are uniquely defined and only depend on the input of and the result of the preceding steps. Okay, uniquely means each and every step should be different from other step. Okay, no duplicate steps should be there. Okay, uniquely defined steps, and the step we are writing, it must depend on the previous steps. It must depend on the previous step. Okay, so it is no unique. Finiteness means the algorithm always stops after a finite number of steps. There should be a stop step is also at the end of the algorithm. It makes the algorithm finite, means total number of steps we can count. Now input, the algorithm receives some input. The first step or the beginning steps must take some input from the user, and after processing there is at the ending position of the algorithm there should be some output must be produced by the algorithm. Okay, now next, what identifies an algorithm? Means algorithm should clearly identify the following. Clearly identify means clearly mentioned there what the input to be taken from the user, what input we need to find the solution of the problem. Okay. Next is processing. What formula is needed? Okay, what process is needed to get the desired result? And then last one is the output desired by the user. What output is going to be displayed by this algorithm? Okay. In the previous example we see all those things. See here. Here it is defined here, it is mentioned here everything. What input we needed. Okay, input, this is the input, this is the processing, okay, processing capability, and this is the output. Output is mentioned that average will be given output. Okay, like this it is given. Now come to flowchart. It is another step and very easier steps to understand the solution of the problem. A visual representation of an algorithm. Okay, after algorithm we have to write this flowchart. Flowchart. A flowchart is a type of diagram that represents the algorithm graphically using boxes and various kinds in an ordered connected by arrows. Okay. Using boxes, diagram in flowchart is just a diagram. Okay, and it represents the algorithm. Using some diagram, using some picture, okay, using some boxes, circles, arrows, using these things we made a diagram of algorithm. For what? Algorithm का ही जो है वो एक diagram picturize कर देता है flowchart, and which becomes more easier to understand. Now, what is the definition here? It is a pictorial representation of a task. It is a pictorial representation of task. It is defined as a visual representation of the sequence of steps and decisions needed to perform a process or task. Okay, visual representation, sequence of steps and decision needed to perform a process. A flowchart depicts flow of a program. Okay, flowchart depicts the flow of a program. Flow means from which step we have to go to which another step, what is the next step. Okay, it knows as the flow of a program. The breakdown of a task into separate steps. It shows all the steps of a process. Being visual means it is picture, it is a diagram, so it helps in understanding the logic of a task quickly. Okay, understanding the logic very quickly. Why it is quickly? Because it is a diagram, it is a picture. Thus, flowcharts are used in analyzing, designing, documenting and managing a process or program. Okay, thus flowcharts are used in analyzing. Analyzing means understanding. Okay, then designing, then documenting. Documenting means writing a separate document, or managing a process in a program. These are the benefits of flowchart. So we have to make flowchart. Every time we want to write a program, we should first write algorithm, then flowchart. Okay. These are the symbols for the flowchart. This is oval. Okay, it is for start and end. Ovals shows a start or end point, start point or end point in a code. This is the arrow, connections. Arrows show connections between different parts of the code. Okay, connections between different parts of the code. Now this is known as process. All the process formula or the computation or the calculation work should go in rectangle. Rectangle shows processes. Okay, your calculations. Most things the computer does that do not involve an input, output or decision. Okay, now this is input output, parallelogram. Okay, parallelogram shows input and output. Remember, print is normally an input. Okay, print is an output, but here we can treat as input because same type of box is needed here. Now this is conditional, diamond shape. Diamond shows a decision or conditional. This is normally if else, if where some condition where we have to take some decisions, some logic capability is there. Either we have to divide the number or we have to multiply the number. For that purpose, this decision box is needed. Okay. Now see the example here. Just what we have made. What we have developed an algorithm. For that purpose, we have developed here flowchart also. Okay, for that same purpose, flowchart to calculate average of 3 numbers. Okay, here start is given in oval shape, then read ABC 3 variables in parallelogram because it is input, so parallelogram. Then average computation work in the rectangle for processing. Okay, parallelogram, then rectangle, oval shape to start, and then print average, print option average, print displaying output is there. Then output in parallelogram also. Okay, same. Then stop is also in oval. Okay, end or terminate in oval shape. Okay, understood? This is the same. This is the flow chart to compute average of 3 numbers, and this is the algorithm to find average of 3 numbers. Okay. Pseudocode. Pseudocode is nothing but it is just like algorithm. Algorithm is having some rules and regulation. While writing algorithm, we have to follow some rules. There should be finite number of steps. Each step must be unique. Okay. There should be input must be defined, processing must be defined, output should be given. Okay, these are the rules in algorithm. But here in pseudocode, these restrictions are removed. Okay, and here we can write solution of the problem in our natural language, in English language. Whatever steps we want to write, we can write. Say for example here, making a phone call. Okay, unlock phone, just unlock phone, open contacts, search for contacts. Okay, place a call and end call. Just like this, simple steps we have to write. Okay. Now here, this is the definition of pseudocode. Pseudocode is a simple and informal way of writing programming code in English. Simple, informal way. There is no rules and regulation. There are in English. Okay, there are no standard rules to write pseudocode. It is used to express our logic. Just used to express our logic, independent of any programming language. Okay, no programming language must be discussed here. Okay, just we have to express our logic here. To express logic, to design a logic, we write pseudocode, and it is independent of algorithm or flowchart or any programming language. Using it, what are the benefits of pseudocode, writing pseudocode? Using it, we can easily break down a bigger problem into smaller modules or subparts. Just it is very much benefit for breaking down bigger problems into smaller problems, okay, or subparts, and gives us better clarity about how we can solve a particular problem or process. Okay, to solve program or a process like this will be benefited. This is the pseudocode, just a simple and informal way of writing programming code in English with no restriction, no standard rules, just to express our logic independent of any programming language, and it helps in breaking down a bigger program into smaller modules or subparts. That's it. See the example of pseudocode. Here we have given you example pseudocode that reads marks of 10 students and display average of marks. Okay, this is the process. Set total to 0. We have taken a total variable to 0. Then marks counter to 1. We have taken counter and it is marked as 1. While marks counter is less than or equal to 10, okay, it is set marks counter set to 1, and whenever it is less or equal to 10, these two steps will be repeated. These two steps must be repeated, okay, till the counter becomes more than 10. Okay, in first step, input the next mark, then add the marks into the total, and then again go to, okay, continue the loop. This is a loop, just it is a loop, okay, and this loop ends when the 10 marks, when total 10 student marks will be inputted, will be taken, will be get, okay. Then after then this step will be followed. Set the class average by dividing total by 10. We have obtained total because total we are doing here. Okay. We are adding marks to the total, and total is set to 0 here. Then each time the total will be counted, will be added by the next student marks, and at the end of this loop the total student marks will be added in this total variable. Now it is divided by 10, average will be calculated, and then display the class average. This is the solution. This is pseudocode. Just it is written in English words, English language, okay, without any restrictions. Okay. Now some exercises given here for you to do it yourself. Okay. Thank you. Hope you understand the concept clearly.